Hi, how's it going? This is David Montoya and Angel Ortiz, and our team is going to present the subject of quantum computers. We humans have been advancing with time, getting upgrade by upgrade. Our best improvement yet involves our minds. Humans' inventions are getting more and more smaller and powerful each time. Computer parts are now approaching to atom size. We can compare this set of upgrades to evolution. Computers have been constant evolution through the years. They're like Pokemons. They start small, well, not that small if we compare them with the first ones, which were big and full of cables, but small like calculators, which they complete simple tasks like addition, subtraction, multiplication, and division. Now we proceed to a more complex evolution, which is the PC, which completes more challenging tasks. And our latest evolution will be quantum computers, which is a great advancement for the world. With this said, let me introduce you to quantum computing. My partner Angela will give you a brief definition of quantum computing.
Hello, my name is Angela. Quantum computing is the use of quantum mechanical phenomena such as superposition and entanglement to perform computation. A quantum computer is used to perform such computation, which can be implemented theoretically or physically.
As my partner Angela mentioned, quantum computing brings whole new properties that are game changers, which are way ahead of normal computers. Such properties produce more results in a shorter amount of time than normal computers. The most well-known properties for quantum computers are superposition and entanglement. In normal computers we have bits that are represented in 0 and 1. And in quantum computers we have qubits that are more complex. Bits can have 16 possible combinations and use only one. Qubits, they can use those 16 possible combinations at once and still increase exponentially by each qubit.
Qubits are fundamental to quantum computing and are somewhat analogous to bytes in a classical computer.
Now,
quantum superposition is a fundamental principle of quantum mechanics.
Superposition stays in both states. This means it can be 0 and 1 at the same time. When it's unobserved, the qubit is a superposition without definition. The instant is measured, it decides its value. The next property will be entanglement, which is a close connection that makes each qubit react to a change in the other qubit's state instantaneously, no matter how far they are. We can directly deduce properties of their partners without looking. Quantum computers cannot replace laptops or desktops, but in some areas they are vastly superior. They do more complex tasks like database search or running IT security, but another exciting use for quantum computer is simulation. For normal computers, simulation is too hard, but quantum computers can make it very easily. When we're talking about the making of quantum computers, we have a race, and the top contestants are Google. As you can see, they use a lot of gold since it's a perfect conductor of electricity. With IBM, which is always trying to improve, and at last, but not the least important, Rigetti, which is a nice competitor. As you can see, all three models are similar, but they have different approach. As we can release, it can be noticed how similar is the beginning of quantum computers to the beginning of normal computers. As you can see in the color pictures, quantum computers are maintained in closed areas with low temperature since they produce a lot of heat. With quantum computer, the rate of advancement in technology will increase, as shown in the Excel spreadsheet at the left and the graph at the right. Technological improvement rate increased each time. We are looking at more advancements than our ancestors did. At the time, we don't know the exact potential of this tool. It can even revolutionize the world, but we don't know the limits of technology. Thank you very much for your attention.
Thank you for your attention. Goodbye.